hop, the greatest story ever told in rhyme. Hip hop, the greatest story. Hip hop, the greatest story ever told in rhyme.
Hello everyone, welcome to Swift Nuggets episode 3. I'm so delighted to present you the next things in Swift and the evolution and the proposals that are coming to us. We are like almost having the WWDC. There are like 9 days or something until WWDC. Today is 29th of May, and I'm looking forward to see what Apple announces. I think the most interesting thing for me is the new redesign of iOS, which I think it will be kind of cool. All right, so since we last spoke, Xcode 16.4 came out. It on build 1.6F6. It was just released. Even though it's saying 27th of May, I think been available for download since today. We have a new Swift 6.1.2 compiler, and it brings the 18.5 iOS SDK plus other SDKs such as macOS 15.5, Vision, tvOS, and watchOS, which is kind of cool. In terms of new things and changes, the release notes don't contain much details. They mention a few resolved issues about the excessive CPU utilization from the disk image COD, which reduces the simulator performance. We have a Apple Clang compiler resolved issue specific to chart rates. And what's a new thing is if you're using XCRun device control diagnose, the command has now been enhanced with a new feature that obtains the sysdiagnose from your Mac and your available devices by default. This is something that was not before. And there's a few resolved issues on instruments and simulator. On simulator, especially the NSURL session was always timing out, and it was failing on iOS 18.3 simulator runtimes. Now this thing has been solved. All right. In this episode, we're going to continue to speak about the new things in Swift 6.2. We discussed a few proposals last time in episode 2 last month, and a few proposals that were mentioned, they were coming and were not entitled or not marked for Swift 6.2 now have been added to the feature branch. And we already spoke about them. The first one is Swift Evolution Proposal 4.6.1, which is about the non-isolated async functions on the colors actor by default. This is a major usability inconsistency where the non-isolated async functions always run on the global concurrent executor. And unlike their synchronous counterparts that inherit the colors isolation. And this behavior forced us developers to do some workarounds when working with non-sendable types across actor boundaries, while the proposal changes the default so that we now we have the non-isolated sync functions inherit their colors actor isolation, introducing new attributes such as add concurrent. I'm not mistaken. Yeah, add concurrent. You need to mark this for explicit concurrent execution when needed. And this change is available through the async color execution feature flag, dramatically improving the developer experience. Well, this is a very cool stuff added to the language, and about the Swift concurrency made a bit simpler for us to adopt. And the second one, we already spoke, and I want to mention it in this episode as well, are the Nonescapable types, which I think are quite awesome and complement the non-copyable types. The non-escapable types are part of 4.4.6 proposal, and they introduce a fundamental, I think we can call it fundamental, new capability to the Swift type system by allowing the types to be marked as tilde non-escapable, meaning their values cannot escape beyond their current scope. These types cannot be stored in properties. They cannot be returned from functions or captured by escaping closures, making them ideal for safe buffer access, resource management, and if you want to do some kind of performance tweaks, optimizations, I don't know. I'm curious what would be the use cases from a bigger project or some projects from domain financing, or I don't know, some real world applications here. While this initial proposal is intentionally limited, no initializer, return values, or generic support yet, it sets the ground for a way of lifetime dependency system that will enable low cost abstractions and safer memory management patterns. This is similar with Rust approach, but it's specific adapted to the Swift's principles. We spoke about non-escapable types, and I think we also have some examples in previous episodes, so please check them out. I think it would be very useful for you. Cool. And let's start with two new proposals that were new and we didn't spoke about and were added to Swift 6.2. The first one is proposal 457, expose attosecond representation of duration. This proposal introduces precision, the attosecond precision to Swift's duration type. There's a structure called duration in Swift, and if you're wondering how much in terms of seconds, it's an attosecond. 1 quintillionth of a second is like 10 at the power minus 18 seconds. To put this in perspective, is to a second what a second is to about close to 32 billion years, 31.7 billion years, roughly. Is considered twice of the age of the universe. And why was this a problem? Well, the current implementation of duration uses int64 to store the attoseconds, which limits the range of representation duration. So this limitation becomes apparent when dealing with very long duration. I don't know, in scientific projects or physics, whatever. And the current implementation can only represent durations up to approximately 292 years, which might not be sufficient for certain scientific or long-term application. All right, so in the video we can see like the duration, which is a structure and conforms to sendable, has two variables, the low and the high, which are both unsigned integers 64. There's no like a representation of an integer like 128. The proposal complements the existing construction and introduces a third approach to store the value using an int 128 bit value. This provides like a direct and efficient mechanism to work with duration values while maintaining the full compatibility of the existing APIs. Try to represent a duration longer than 292 years will encounter an overflow error with the current implementation because it's a 64. And the proposal introduces a new internal representation that can handle a much wider range of durations while it maintains the precision. So it's essential for ultra precise timing. If you have like financial applications, scientific projects, as I mentioned, you have a better way to handle this. All right, cool. And the second new proposal that has been adopted by Swift 6.2 is the isolated synchronous deinit 371. This proposal introduces an isolated synchronous deinitializer. Well, this looks like a game changer for how we handle cleanup in an actor isolated type, for example. What does it mean? So if you're working with a main actor class, that like a class which runs on the global main actor that needs to perform some kind of a cleanup when it gets deallocated, Before 6.2 and in the current released version of Swift, this was tricky because the initializer couldn't access the isolated state. This led to some awkward workarounds. In the case of several instances with shared data isolation on common actor, the problem is completely eliminated by in this proposal. So we can put isolated deinit and we can like do it and do the cleanup in the deinitializer. And we have a bunch of future Swift proposals. I will start with 419, Swift Backtracking API. First of all, a backtrace. So it's Swift Backtrace API 419. It mentions like we're improving the usability of Swift for command line and server-side development by adding first-class support for backtracing to Swift. What's a backtrace? A backtrace or a stack trace is like a breadcrumb, a trail that shows us exactly where our code was executing when something has happened. Think of it as a snapshot of your program's call stack at a specific moment. And before this proposal, getting detailed backtraces in Swift was tricky and often required like some third-party packages. The backtrace structure of the proposed solution will capture an array of frame objects, each of which will represent a stack frame or a task activation context. It should work across all Swift platforms. It captures sync frames and task contexts. It shows file names and line numbers. So this proposal is quite nice to find a backtrace to the APIs and to the Swift backend world. I think it's very powerful debugging capability, and it adds a good thing in Swift, making it easier to understand what's happening in the server backend applications. And whenever you're building, for example, a testing framework or need a better error reporting, this API provides the tools you need. And you have here in the proposal very detailed information. You have a structure symbol info that contains a lot of parameters. Those are good things because it will because they will detail the stack trace, the backtrace the program has. For usage, we need to import the runtime framework. We can allocate the backtrace variable, and we call the capture method. And if we want it to be symbolicated, we just call symbolicated the function, and that's it. And then we can do whatever we want with this. In a future Swift proposal, we might have the isPower of added to the binary integer. This is the Swift proposal 288. It introduces a new method called isPower of, but this is too specific to binary integer protocols. And it's exactly what it sounds like, a way to check if a number is a power of another number. The implementation is straightforward. You have the number itself, and you call it dot is power of another of the next number, and you'll get a boolean back if it's true or false. It's the method is small but significant addition to the Swift standard library. I think it makes the code more readable and maintainable, while still maintaining the good performance, because the guys that wrote the proposal thought about the inner works and have the algorithm to work in an efficient manner. Generic math functions. The next proposal is Swift Evolution Proposal 0246. It's not been implemented in Swift because it has a source breaking consequence and some problems with the performance and shadowing rules. Hopefully, this will be resolved in a future version. It has been accepted since 2019, so it's quite old, but might get updated at some point. And the intention is to introduce two new protocols, elementary functions and real. And these protocols combine way to provide basic math functions for floating point and sim types and provide a path to extend that functionality to planned complex types in the future. Next one, 283. Tuples conform to Equatable, comparable, and Hashable. This is an old one as well. It wants to introduce those protocols, Equatable, comparable, and Hashable, to all two tuples whose elements are themselves equatable, comparable. So it's an addition to tuples. Tuples in Swift have long been a source of frustration for developers who want to use them in collections or perform some basic operations like comparison. And this proposal addresses the limitation by allowing them to conform to these three fundamental protocols: equatable, comparable, and hashable. Before this proposal, trying to use tuples in common scenarios will result in compile errors. So if you have like contains or sorted and so on, you'll get a problem. Next proposals which I'm going to talk is the package registry service, publish endpoints with proposal 321. SPM has evolved significantly since its introduction, and 321, this proposal introduces a crucial feature, the ability to publish packages to a registry. These registries have been implemented in Swift 5.7, if I'm not mistaken. And before this proposal, the package distribution was primarily done through the Git repositories. Next proposal, Swift Evolution Proposal 342, statically links with runtime libraries by default on supported platforms. What does it mean? So we have a fundamental aspect of Swift application deployment, how runtime libraries are linked. This proposal changes the default linking behavior to static linking on supported platforms, bringing significant benefits to application deployment and distribution. And traditionally, Swift applications have relied on dynamic linking for runtime libraries, which means like applications depend on system installed Swift runtime libraries. We have different versions of the runtime that can cause compatibility issues. Deployment requires ensuring the correct runtime version that is available, and applications might be vulnerable and are vulnerable to runtime library tampering. With this change, now the default linking will be to static on supported framework. It provides some cool benefits. We have like improved deployment. We don't need to install Swift runtime libraries separately. Applications are self-contained. We have some enhanced security, and the performance might be a bit better. The next proposal, 454, memory allocator, custom allocator for toolchain. This proposal introduces a new memory allocation API in Swift, which gives more control over memory management and enabling better performance optimization. So we have a new thing called memory allocator. 471, improved custom serial executor isolation checking for concurrency runtime. And this adds isIsolated to the serial executor protocol, enhancing the Swift concurrency model by providing a better control over the actor isolation and execution context. It's crucial, this aspect. So when you have an actor and the execution context, it's needed to ensure the proper actor isolation, to prevent data races, to manage the concurrent access, and to debug the concurrency issues. But there was no reliable way to check if code is running on a specific executor. So this proposal adds a property, an isolated property to the serial executor. And we now know if it's there or not. Next one, ABI attribute. Controlling the ABI of a function, initializer property or subscript added in proposal 476. It proposes the introduction of that ABI attribute, which is an alternate version of the declaration used for the main. We have more control over the ABI, application binary interface, on the code itself. And you have a better management for binary compatibility and more precise control over how Swift code interacts with other languages and systems. So if you work on an ABI library or whatever, you have now with this ABI more control over it. 477 default value in string interpolations. It's touching the strings here and adds, as like you might guess from the title, a new syntax to provide a default string when we have an interpolating with an optional value. This we can specify now the default values for interpolated expressions and makes string interpolation more robust and reduces the need for the nil coalescing operators. If you don't have that value, you'd probably use like question mark, and then put the default value of the string. This is how it's done right now. And the proposed solution is actually include the default keyword here and then put the default word that you want. Even if it's an integer, you could put the default value here. And it's no matter what the type of the value it is. In terms of implementation, the new interpolation will add it as an extension to the default string interpolation type, which kind of makes sense. Next one, quite an awesome one, weaklet. Yeah, you heard right, weaklet. I think it's a very cool addition to the Swift memory management system. The ability to declare weak constants using weaklet and enhance the memory management capabilities for Swift, where we can create weaklet references. And now we would always use variable and which were stored. The common example is the delegate part, where we could like use weak power delegate. Now we references become nil when the object is destroyed, causing the value of the variable to seem to change. This causes unnecessary friction with sendability checking. That's the reason because weak references must be mutable. Classes enclosure with such references are unsafe to share between concurrent contexts and so on. This proposal lifts that restriction and allows weak to be combined with let. So now we can say weaklet delegate, and we can put it as non-optional in our usages. I imagine this comes with a lot of real-world application in a lot of code bases, like have parent-child relationships, navigation controllers. You can have it in tab bar controller and so on. And also helps the memory. It gives like resource cleanup, better way of representing the non-optional type. But you can also place it as optional. Cool. Binary static library dependencies, Swift proposal 482. Extends the SPM binary target support to include static libraries on non-Apple platform. This proposal fills a crucial gap in Swift's PM package manager's cross-platform capabilities, bringing the same binary distribution benefits that Apple platforms have enjoyed to Linux, Windows, and other platforms. Before this proposal, the binary target support was limited. We had like platform restrictions. It only worked on Apple platforms. We have limited library types, no support for static libraries like .a files, cross-platform gaps. Non-Apple platforms couldn't use pre-built libraries, and we had like integration challenges with C, C++ libraries, for example. And finally, Swift proposal 484 allowing additional arguments to add dynamic member lookup subscripts. This one, when we worked some kind with the JSON or we didn't know the keys of that JSON, we could use a dynamic member lookup and we could then at runtime discover the properties and take the values out of the properties. But it came with a limitation. We could not do more than one parameter when we introduce the subscript when we search for the property. And with this proposal, we now can have multiple parameters to the initializers and multiple arguments, additional arguments beyond the member name. This proposal makes dynamic member lookup more flexible and powerful, I guess, and we can show it in an example. I have here a demo project as Swift UI application, which executes around playground function. And we can have an initializer that sets that data. And here we would usually have a subscript that has a dynamic member property. Here we can return string. Right? And we can say data, which is a dictionary of string. We can say data, the name of the property, and return it here in the function. All right, and this plays out like this, allocating a new container, some data, let's say city as a key, and have Los Angeles as the value. And if I would print the container.name, which is like if I'm not marking the container with dynamic member lookup, I get an error because it doesn't find the property. But if I put it like that, then I get it's working fine. And in case it doesn't find, let's print unknown. Right, and here I'm using as a key city. So if I'm using like data.name, it will use data of the name, and it will simply print unknown because it doesn't find anything, right? But if I'm doing container.city, it should give me the Los Angeles. Prints Los Angeles because that key was found. It's right. So you see it's here. That's the purpose of this dynamic member lookup. You don't know at compilation time the exact names of the field, but at runtime, when you parse or, for example, get a JSON back from the backend API, you use it there and extract the values. All right, and in current world, if I'm having a second subscript, for example, dynamic member name, let's use the same approach, dynamic member name, and I want to put a second here parameter default value. Let's say default. This won't work. I'm using the return default data name. If not, return the default value. All right. So if I'm trying to do container.city or .name, if not use the default value unknown, something like this, I get the compilation error, cannot call value of non-function type string in our case. It's not working. But with the new proposal, this will totally work. All right. Thank you very much, everyone. Thank you for listening. Can't wait for the WWDC in 1 week and a bit, a few days. Hope it was interesting and see you next time. Bye.
Like greatest story. Like greatest story ever told in rhyme.